Okay, guys, now we're going to talk about forces, which is a vector quantity. Now, force is either a push or a pull upon an object. It's either a push or a pull upon an object. This force can cause the object to change its speed, direction, and shape, but it can never cause a change in the mass. Okay? Now, forces in general are measured in newtons, that's the unit, so any force is measured in newton. We said we can measure the force using Newton meter, spring meter, force meter, all of that. So since force is a vector, so it can have a positive or a negative value according to the situation that you're facing. Now, if it's a driving force or a force that causes the object to move, it's a positive force. If it's a resisting force, which is in the opposite direction, it's a negative sign, so it causes the object to slow down. Okay, now let's talk about the types of forces. The first one is the weight. We already talked about weight. It's the effect of gravity on the mass of an object. And then we're going to talk about the normal reaction. Now, a normal reaction, as it says, it's a normal reaction force. So when you exert a force on an object, the object itself exerts an opposite force on you. So, for example, this book is exerting a force of 50 newtons on the table, so the table react and gives a 50 newton back. So that's when two solid objects are interacting with each other, so the normal reaction is applied or is created. Okay, excellent. Now for friction force. Now friction is a force that opposes the motion and it impedes the motion. Impedes the motion means it slows it down, creating some sort of a heating effect when an object moves. So for example, this car is moving this direction, so the friction is in the opposite, and so on. So if we're going to talk about this car, so the friction should be what this in this direction. Okay, excellent. Now types of friction can differ, so there is the helpful one and there is the unneeded. So helpful one, it one produces heat, helps you to move, or it helps you to stop basically. Okay, unneeded friction like engines when you try to speed up, and any other activity that you don't really need the friction in. So usually you reduce friction using some sort of a lubrication like oil or water that can be used in examples. Okay, now moving on to fluids forces, or what you call the first one, which is the drag force. So fluids are like gases and liquids. So you got air resistance and you've got water resistance. These are forces created from friction with air or friction with water. Okay, so if your speed increases or your surface area increases as you are cutting through the fluid, which means liquid or gas, so therefore the drag force is gonna subsequently increase. So increase the speed, increase the surface area while you're moving really quick through air, what's gonna happen? Air resistance is gonna increase. If you're gonna move quickly on water, also the water resistance is gonna increase. If you have a large surface area while you're doing that, also the drag force is going to increase. Okay, but also if you decrease your speed or the surface area, these two are going to decrease. So this also is a type of a idea they usually say what happens to the forces when the object slows down. So you'll have to say what the resisting forces also decreases, so keep that in mind. Now we talk about the upthrust. Upthrust is the force created due to the interaction with the molecules of the surface of a fluid. Basically, this ship is sitting on a bed of water. So imagine these water molecules are being pushed by the weight. So they come and they push back against the boat and they create the upthrust force. Okay, usually the upthrust is always equal to the weight. This is what you should learn in O level. Now we're gonna talk about the resultant forces, or how to get the resultant force or the sum of a force. Now these forces, when they act on an object, according to their direction, we add them up. This is relative to the idea of vectors. Now it's called vector analysis. When two vectors are acting on the same line in the same direction, we add them up. So the resultant would be 60 plus 30, that would be 90. For example, this one is 30 minus 10, so the resultant is 20. So this was driving force, and this was the resisting force. This was the driving, this was resisting. Okay, so that's how you calculate them if they are on the same line. Okay, now for the ones on the right angle or at an angle to each other, that's a different analysis we're going to talk about in a lesson for itself. Thank you.